Alright, so in this video, I'll be showing you how to calculate the percentage composition in a compound. So let's say you want to find the amount of, in percent of carbon in that compound or hydrogen and so on. So this is the important formula that you have to know when it comes to percentage composition. And I'll be using this formula later on anyway, but if you want to write this down, you can write this down. So I'll just go straight into an example problem, which is asking us to find the percentage by mass of each element present in C6H5NO2. So to find the percent composition of carbon, let's write this down. To find the percent composition of carbon, hydrogen, nitrogen, and oxygen. So the first thing you always have to do is find the total molecular mass or weight of the entire compound. So we want to find the molecular mass of this entire compound, C6H5NO2. And that's because, right, we want to find the percent composition of C, H, and N, and O. So to find the individual percentage compositions, we have to divide it over the total, right? Like, it's logical. Like, let's say you want to find the percentage of this or whatever, right? It's always the fraction of that divided by the total amount. But going back, right, so we have to find the molecular mass of C6H5NO2. And so we do that, right, by breaking down this compound. It has 6 C's, right? That's why 6 C's. It has 5 H's, 5 hydrogens. It has 1 nitrogen, and it has 2 oxygens. And to find the molecular mass of this compound, it's very simple, where we just have to do this here. So 6 times 12.01. What are these numbers here? These numbers, to make things simple, are the average weight or the weight of one single atom of that atom. So let's say carbon, right? 12.01 here represents the weight of one carbon. Since we have 6 carbons, we logically multiply it by 6 times, right? So this is for one carbon atom, but we have 6 carbon atoms, so it's 6 times this. And where do we get these values? We get them from the periodic table, right? So let's say, for example, here, carbon. The average weight of one carbon is this number here, 12.01. For nitrogen, 14.007. For oxygen, for oxygen here, it's 15.99, roughly 6. And for hydrogen, it's 1.008. So that's where we get those numbers. And again, right, makes sense. We have 5 hydrogens. One hydrogen atom weighs 1.01. Since we have 5 multiplied by 5, so 5 times 1.01. Same thing for nitrogen. We have 1 nitrogen multiplied by, because we have 1 nitrogen, it's only, and this is the average weight of 1 nitrogen, so 1 times that. And we have 2 oxygen, so 2 times that. And we get the sum of all of this to be the molecular mass of this entire compound, C6H5NO2. So that's our first step, and we're done with that. So our second step now is to calculate for the percent composition of each of these elements. And so we have carbon again, we have hydrogen, and we have nitrogen and oxygen. So to start with carbon, to find the percent of carbon, we have to recall the formula from before, where the percent mass of an element is the number of atoms times the relative atomic mass times the relative molecular mass. So to break this down, the number of atoms you get from here. So carbon, right? How many atoms of carbon are there in this compound? 6, right? There's 6 carbon atoms. So it's 6 times the relative atomic mass. What is the relative atomic mass of carbon? From the periodic table, we know it is 12.011, right? Just like before. So it's times 12.011. And what is the relative molecular mass? That is the total mass of this compound, which we calculated before as 123.097. So divided by, 123.097. So again, I do it here as well. So it's the number of atoms of C, which is 6, times the relative atomic mass of carbon, and one carbon is 12.011, and the molecular mass of this entire compound, which is 123.097. So we do that here, like we did here. multiplied by 100, and the reason why we multiplied by 100 is because we're finding percent, right? The percent of this, so it is 58.53% if you do this calculation. So that's for carbon, and I'm pretty sure you get the drift of how this works. So moving on quickly to hydrogen, same thing. So what we have 5 hydrogens, right? So it's 5 times the average weight of one hydrogen, so it's 1.01 over the total mass of this entire compound, which is 123.097 times 100. Because it's in percent, we get 4.10% of hydrogen. Same thing for nitrogen. Well, it's only one nitrogen, right? So there's only one nitrogen here, times the average weight of nitrogen, of one atom of nitrogen over the total mass of the compound, times 100. We get this. So we got this. And lastly, for oxygen, there's 2 oxygen. So it's 2 times 15.99, which is the average weight of one atom of oxygen divided by 123.097 times 100, and we get this. So these are the percent compositions of each element, and if you add them, 25.99 plus 11.38 plus 4.10 and plus here 15.53, 58.53, it should equal to 100. And if you get 99.99 something or very close to that, that can still be considered correct. So that's it for this video. If you have any questions, you can always ask me in the comment section below. Thank you.